Today we're going to talk about the design process. The design process is an iterative and innovative approach to solving problems. The first step is for us to understand the problem. That is to carefully decipher what are our design considerations, what is the problem, and try to simplify that problem and refine it so that we can best understand it. The next step is then to identify what we call the knowns, which are the parameters that are given to us from our design considerations or the constraints that we have in our design, and then to identify the unknowns, the quantities and parameters that we need to solve for. Once we have the knowns and unknowns in hand, we can then formulate a solution strategy. That is to figure out what are the equations or the theories that we need so that we can solve for our unknowns. With the most important formula being that the number of equations that we have needs to be equal to or greater than the number of unknowns. If we have that condition, then we are able to actually solve our problem. The next step is for us to state our assumptions and to make declarations of our decisions. In real designs, in the real world, things are complex and it's hard to find closed form solutions. So often we have to make assumptions that simplify the problem and allow us to actually apply fundamental equations to that problem. Also, sometimes decisions need to be made about, say, how a design is constrained and that information isn't available. So we have to make a choice or a decision. We are going to choose this as our constraint in order to solve a problem. With all of that set up, the knowns and unknowns, the solution strategy, we can then go about analyzing the problem. And that's where we actually do the mechanics, the mathematics of solving a problem, right? Going step by step, labeling our equations, rearranging and trying to solve them with a goal of trying to keep our equations in variable form. Instead of doing intermediate calculations, every step you're doing a calculation, keep everything in those symbols. In the, length is L rather than length is equal to 10 meters, so that you can get a clear solution to your problem at the end. Once we've gotten our solution, we've got an equation that we can input our values in and solve for a number. We then need to evaluate our solution. We need to check that the steps that we took in order to get to the solution are valid. We need to check our equations. We need to evaluate if the assumptions and decisions that we made are correct. We need to check for the units and make sure that they're actually homogeneous, meaning the units on the left-hand side of the equal equation are the same units as on the right-hand side, right? And then finally, once we've evaluated our solution, we've got some confidence in the numbers that we found, we then need to present our solution. Now, as engineers, we don't work alone. We are not a sole engineer. We're not designing a car by ourselves. We work in teams of other engineers. And if we want our solutions to work, we need to be able to communicate our solutions. We need to have properly written out instructions on how we solved our problems. And then we need to present them to our team for acceptance or rejection, for a design review, right? And the goal is not to argue with our teammates or to try to say, well, I'm right and my all my assumptions or decisions are correct. But rather, our goal is to try to gain feedback, to try to make sure that collectively as a team, the solution we have is the best, and so that we can move that design forward and continue to iterate.